see off campus. So basically the general purpose, we wanted to see if we could test alcohol in the air, more or less on the breath, but to minimize it for demo purposes, we actually don't take into account weight, hours, amount of alcohol consumed because we can't demo that.
Yeah.
So what we decided to do is we use mouthwash, and it works really well. So,
and another thing is that there's no actual set standard formula for measuring blood alcohol content. Each country is different, and United States, actually some states are kind of measured differently as well. So some measured by like parts per liter, other measured by like parts per like volume of your mouth, and it's kind of interesting how they measure certain things. So we went ahead and just went with percent alcohol.
Yeah.
That's a little bit more standard.
So in the meantime, I'm going to be switching that way when we demo. It'll be good to go.
Yeah. Okay, we'll go ahead and go with the requirements, but it's basically, it's similar to Lab 5 a little bit in the essence that we're reading in from the sensor. We actually got the sensor from SparkFun, and one thing that kind of came up is that documentation for said sensor is terrible. They like don't even tell you how to properly wire up the system in the first place. We went through about 3 or 4 different wiring schemes, just going like, what? You know, this is not even working. And so, thankfully, there was actually a couple of guys who'd actually done a project very similar to ours, and SparkFun had already linked to them. There was like 3 or 4 different people. After going through about like the second or third person, we found an actually decent picture that helped us set up the sensor correctly. So that was one thing.
It's actually really sensitive. We decided there was 3 different recommendations for a resistor, and we decided to use 2.7 because it actually pulls it down to where it's within the range of 0 to 3 volts.
Yeah, because it's normally a 5-volt device, but since we're dealing with a 3v3 on our board, we have to make sure we didn't blow something up.
All right. So basically, I just recreated from the bottom view. You can use actually both. These are B input, or yeah, B pins, A pins, and you can use each side independently. Like you could actually flip flop this design just as long as you keep the wiring the same. You can actually put the sensor in a different position. The block diagram is very similar to the sensor that we use with temperature. We just replaced it with the alcohol sensor. We use the LCD we displayed from 0 to 100% alcohol in the air. You actually have a little bit of alcohol in the air always. It's about 3%, sometimes less, sometimes slightly more. Software, we just use the digital export, the Xilinx and SDK.
And the sensor is actually kind of particular because it uses a heater unit. So when you initially charge it up, it takes a little while to warm up, but if you stick your finger on it, it's actually like will burn you.
Yeah.
You got to be careful with that. We learned that the hard way. Yeah, that's what these central pins right here. It's like it's the plus and minus on the heater, so it warms up the sensor, and then the sensor uses the effect of the alcohol on that heater unit to give us a
we initially had both of these all bridged together.
Yeah, we had all 6 wires.
And it was actually, if we would have left it on longer, it might have melted a little bit. So,
so thankfully we realized our mistake and moved it right up.
all right.
This was initially where I was going to come in, but like I said, BAC is calculated differently depending on kind of where you are, and a lot of it is dependent on your body weight. And even then, they use a rough estimation of the way your body breaks down alcohol. So use your body weight, but then they say like, well, a certain 185 per pound person breaks it down at such and such a rate, but certain people who are slightly more dense can break down alcohol a little bit faster, and so they might actually appear to have a less BAC than they really do. And so again, we ended up sticking with alcohol percent measurement just because it's a lot more clear cut.
Actually, really interested when researching alcohol, just the breathalyzer in general. You can actually use mouthwash, and it can increase the content in your breath by like So when you were drinking and driving, you do a little mouthwash. They can actually wait 20 minutes because it dissipates. So it's not a fail.
So it's just like, oh, it's like I hold my breath because I just brush my teeth or whatever. Like, okay,
yeah.
let's
We'll
just
wait
stand
20
here
minutes and then you blow
see
again.
how that goes.
It actually drops it down.
Yeah, you can just keep blowing, it'll like keep dropping.
Yep. All right. Well, it's about time for demo.
Yeah. Sensitive as heck, but
And
it's only like 1%. So.
And you can actually see it on the scope.
Yeah,
we have it probed at the same part.
Yeah, we've got this will actually show the alcohol on the scope, and we've got a LCD readout as well. So right now we're getting about 3% alcohol, and that's giving us a very low baseline on our voltmeter. So yeah, so like if I just blow on the sensor, it only goes up about 1%. It's not really going to do that much. If you dissipate it, it goes out. But then if Nick blows on it, who's been hugging mouthwash, it jumps right up, and it'll climb too. Like if we had a fresh bottle of alcohol, it just skyrockets. We even just had a damp rag with alcohol just sitting a couple feet away. It was like 60%, just like on average.
Yeah.
So it was like it had a proximity sensor for alcohol.
Yeah,
so.
it wouldn't even have to be near it as long as it was in like a 3-foot radius. It would
It
have.
was just like, whoa, okay,
Yeah.
we're like saturated right here. So yeah, so that was a problem.